Hi guys, so this is the second video on Math SL, differentiation, chain rule and product and quotient rules. So we are going to tackle the four questions present in front of you on the screen, and I'm going to start with question 1 shortly. So our first question came in paper 1, May 2006, question number 5. Take a minute to look at the question, try to solve it, pause the video, and then check the answer out. So for question A, we have f of x equals e to the power of 5x. If you want detailed explanation of the chain rule, you can check the video that tackles that. However, for the purpose of this video, we're just going to go quickly through the simple chain rule problems. F dash of x is obviously equals to 5e to the power of 5x. For b, if the function g of x equals sine 2x, then the function g dash equals 2 cosine 2x. Now, the purpose of this question in the case of this video, in context of this video, is to tackle question number C, where we have h of x equals e to the power of 5x times sine 2x. Now, we have two different functions of x multiplied by each other. H of x is equal to f of x times g of x. So we are going to use the product rule. Now, the general formula for the product rule is available right there in green. If h of x equals the product of two functions, then h dash of x equals uv dash plus vu dash, where u is the first function, here called f of x, and v is the second function, here called g of x. So my advice for you is to first identify your u, your v, your u dash, and your v dash before writing down the product rule and beginning to solve. So don't try to do this in one step. First identify your four variables. So what are the four variables here? Obviously, u is f of x, so u equals e to the power of 5x, and v is sine 2x. Now, for u dash and v dash, we already found the derivatives in questions A and B. So u dash is 5e to the power of 5x, and v dash equals 2 cosine 2x. All that remains for me to do is to plug these expressions into the green formula right there. So we start by u v dash. U is e to the power of 5x multiplied by v dash, which is 2 cosine 2x. So for the first component of the product rule, I multiplied u by v dash. Now for the second component of the product rule, I'm going to multiply v by u dash. So we get sine 2x multiplied by 5e to the power of 5x. All that remains for us to do is to rewrite the expression in a nicer way. Of course, this is a correct final answer right there in red. However, if you would like, you can rewrite the answer in a nicer looking way. So we have 2e to the power of 5x cosine 2x plus 5e to the power of 5x sine 2x, and the problem is done. Now take a minute to copy this down, pause the video, because shortly I'm going to remove this question to begin the next one. Now the second problem we are going to tackle in this video came in paper 2, November 2009, question number 2. Kindly take a minute to look at the question, attempt to solve, pause the video, and then check your answer. So for question A, this is obviously very simple. F of x is cosine of 2x, so f dash becomes negative 2 sine 2x. And for question B, we have the function len 3x minus 5. So the differentiation of len x is 1 over x. So len 3x minus 5 becomes 1 over 3x minus 5 multiplied by the derivative of the inside function. The inside function is 3x minus 5, so the derivative is obviously 3. Now just to rewrite it in a nicer way, I'm going to write it as 3 over 3x minus 5. Now for question C, as I've mentioned earlier, we're going to start by the chain rule, by the product rule, and we're going to first identify our 4 variables. U is cosine 2x, which is the first function. V is len 3x minus 5, the second function. U dash is the derivative of the first function, and V dash is the derivative of the second function. All of these variables have already been found in questions A and B. All that remains is to plug the 4 variables into my formula. So U, then V dash, and then V, and then U dash. Now this purple equation is a satisfactory final answer. However, you can choose to rewrite it more neatly, as you can see right there. And the problem is done. So take a minute, copy this down if you will. I am going to begin question 3 very shortly. So our third question in this video came in paper 1, November 2007, question number 9. Take a minute, try to figure this out, and then check your answer. So now would be a good time to pause the video. So the answers are right there. Before I start my explanation, maybe pause the video again, try to check the answers, and then wait for the comments. So again, with question A, the answer is pretty simple. The differentiation of sine 3x becomes 3 cosine 3x. For question B, you have y equals x tan x. So we start by identifying our variables, because we have 2 functions here, x and tan x. So we're going to use the product rule, obviously. So you have your u, your v, and their derivatives, u dash and v dash. And then you write down your product rule and you substitute. So your answer becomes x sec squared x, which is uv dash, plus tan x times 1, which is vu dash. So this is pretty simple. For question C, this is the first time we meet the quotient rule. We have len x over x. Again, these are 2 different functions of x, and we are going to again name our variables u, v, u dash, and v dash. And we're going to write down a different rule now, but it's pretty much the same idea. We have vu dash minus uv dash over v squared. So you're going to notice in the formula that I put uv dash between brackets. And the reason why I did that is because we have a negative sign before the second term of the numerator, and sometimes the second term is in itself a negative term. So what you want to do is you want to put it always between brackets so that you don't confuse the 2 negative signs. This is just a tip for you. Now we're going to substitute again. V u dash is right there, so v is x and u dash is 1 over x, minus uv dash, which is len x times 1 over x squared. And in the final step, all I did was I simplified the numerator a little bit. X times 1 over x gave me 1, and len x times 1 is obviously just len x. So maybe take a minute to pause the video if you want to copy this down before I begin the next question. So the fourth question to be tackled in this video came in paper 2, November 2005, question number 7, double I, Again, pause the video, try to figure this out, and then wait for the answer. So this is what we call a show that question, where the required final answer is actually given to you right there, and you're required to differentiate the original function to reach this function. So we're going to assume that the original function is actually just 2 to the power of x over x to the power of 3, simply because the minus 1 part is going to vanish when we differentiate because 1 is a constant. So we're just going to assume that the first part is the function we're interested in, and that's quite fine to do. This is a quotient rule question, obviously, because we have two different functions of x and they are in fraction form, they're divided by each other. So our u is right there, 2 to the power of x, our v is the denominator, x to the power of 3, and we're going to differentiate them to obtain u dash and v dash. So for those of you who are not aware of that, the derivative of 2 to the power of x becomes 2 to the power of x ln 2. The derivative of 5 to the power of x becomes 5 to the power of x ln 5. So you're just going to keep the expression as it is and multiply by the ln of the base. Now we're going to substitute these values in the expression for the quotient rule, and again, do not forget the brackets after the negative sign in the numerator. So vu dash is x to the power of 3, that's my v. U dash is 2 to the power of x ln 2, obviously, and uv dash is 2 to the power of x and 3x squared. And you can see the individual expressions in blue, and we just substituted them into the formula. Now for the denominator, we have v squared. V is x to the power of 3, and then we're going to square that to obtain the required expression. Now, in order to reach the show that expression given above, we're going to have to do some factorization. If you don't know the basics of factorizations, maybe you need to review that, but just the simple part of it is that you plug out the common factors of two expressions that are right next to each other. So I have two expressions in the numerator, x to the power of 3 times 2 to the power of x ln 2, that's my first expression, minus 2 to the power of x times 3x squared. I'm talking about the numerator of the fraction. Now the common factors here are, of course, x squared, because we have x cubed and x squared in the numerator. So I'm going to plug out an x squared. And we also have a repetition of 2 to the power of x. So we plugged these out as common factors, and we're going to write down what remains. So I had x cubed, so I have an x remaining, and the ln 2. These are the remnants of the first component. And for the second component, I just have a 3. For the denominator, I have x to the power of 3 all squared, so I just multiply the exponents and I get x to the power of 6. Now this has begun to look a little bit like the expression that I am trying to reach. We have the same bracket, x ln 2 minus 3, but we just need to simplify a little bit to get the rest of the expression straight. So we have x squared in the numerator and the x power 6 in the denominator. I just cancel these out and I get x to the power of 4 in the denominator, and the rest of the numerator is 2 to the power of x times x ln 2 minus 3. So you can take a minute to take another look at the answer, maybe pause the video to write it down if you will, and that concludes our second video on chain and product rules, and I hope you found it very beneficial.